So this is our final project report of the Spotify recommender system. Our group is consisted of Anthony Yu, myself, Ashwin Kumar, Harrison O'Neill, and Joseph Lee. To first introduce our project, what we're trying to do is essentially we're trying to create a machine learning algorithm that recommends songs based off of Spotify data. We placed a specific importance on actually trying to recommend lesser known artists, as when we look at Spotify's recommender system, they do generate and recommend new songs and artists based on your personal data that more or less fits or is closer to your personal preference in music, but they do tend to recommend more popular and well-known artists. And so we try to place the emphasis on trying to recommend music not based on popularity, but based on more of the musicality of the song itself. So in our new approach, or in our approach, we got our Spotify dataset off of Kaggle that had access to data about not only their artists, but also their popularity, different variables such as acousticness, sensibility, instrumentalness, speechness. We also had songs that were classified by their genre and by their year. And as I said before, we placed a specific importance on recommending songs based on only their musicality, things like what kind of genre these songs are in. As I said before, looking at all the variables and the values for those variables for certain songs and how they correlate to maybe your personal preference in music instead of just the popularity of an artist. So who cares? And if we are successful, what difference would it make? So obviously, the lesser known and the smaller artists would potentially benefit from this kind of a system of recommendation instead of because we did not look at popularity as a variable to recommend certain songs. We hopefully hope that this kind of recommender system can work to increase the popularity and give more spotlight to those that are receiving less of it, maybe do deserve it. So certain risks that are involved with our project is just because of the sheer size of our data set, things like our unsupervised learning methods of k-means did take an extremely long time to run. And also we wanted to differentiate between artists that are active and inactive. So there could be artists that has like one follower and one song that they've released in 10 years. So we wanted to be able to effectively differentiate against those types of artists. There was really not any cost, but as I said before, the time that it took was quite a lot just because of the size and the sheer information, the amount of information in the data set itself. Next, I'll just hand it over to Ashwin to talk about the summary figures.
Hey, so in this portion of our report, I'm going to talk about some of the features and how we determine which features to use. Our data set consisted of 20 variables. Each entry had 20 variables, so we had to cut that down. Here we can see some variables such as tempo, valence, liveliness, instrumentalness, etc. So as you can see, variables like valence, there's a large difference between a lot of the variables, whereas in um, variables like instrumentalness, all of the songs have around 0 or between 0 and 0.1, so that wouldn't be a very helpful feature to use when we're trying to group the songs together. If you scroll down a little bit more, you can see our table of clusters, and you can see the losses for each number of clusters. From this, we determined that the perfect amount, the optimal amount of clusters would be 25. So then a little bit of background on our data set. Our data set, we downloaded our data set from Kaggle, and our data set consists of nearly 600,000 songs. As I said earlier, each song has about 20 variables, some of which are on the graphs above. But 20 variables is too many, and so we had to use PCA to perform dimensionality reduction to make our data a little bit cleaner. So we initially brought it down to 10, but we've discovered that it would actually be better to even bring it down one more to 9 features. So I'll hand it off to Harrison, and he can talk about our unsupervised and supervised learning algorithms.
Okay, so to begin, we created this system that would download our data locally and then import our important metrics into an array structure. We then implemented a k-means clustering algorithm to properly cluster our songs together. Through our experimentation and using our loss curve, we were able to find that 25 clusters were the optimal number of clusters, both computation-wise from the curve. Uh, Additionally, we use these clusters as the building blocks to our recommendation engine. If a user enjoyed a song in a cluster, we're able to recommend another song from the same cluster as they will both have a similar sound. After performing the k-means, we then moved on to our supervised learning portion. Here we used dimensional reduction and implemented multiple supervised learning techniques. We first began using linear regression, then linear regression with PCA, and linear regression with SVD, all of which gave us accuracy of around 10 to 11%. We then transitioned to a random forest model, which gave us an accuracy of around 95%. If you're going to scroll down. Using these results, we were able to determine the cluster. Using our supervised learning, we determined the accuracy by using our cluster from our unsupervised learning as the target, and then testing how well our supervised learning testing results compared to that target, and whether the data point was properly classified or not. I will now hand our challenges off to Joseph.
Right, so while creating our Spotify recommender system, we faced a good number of challenges. The first challenge, the first challenge that we faced was that the data set was extremely large because it contained 586,672 songs, with each song having 20 distinct variables. Since there were so many variables, we had difficulty deciding which variables to use and which ones to cut. The main difficulty with the unsupervised learning portion was that since our data set was so large, our k-means algorithm took a really long time to run. This limited our progress because it would take hours to check if our code was running properly. The biggest challenge with the supervised learning was choosing which algorithm to use. After trying a number of different algorithms, we saw that the random forest algorithm had the best results. This made sense because our goal was to group and match appropriate songs rather than determine appropriate trends. And the hardest challenge came up during the last stages of the project. After performing our dimensionality reduction, we found that 9 variables were the most efficient and effective. However, in running a feature importance test, we found that the importance was skewed heavily towards one variable because it wasn't normalized. And normalizing this one variable at the end of the project turned out to be extremely time consuming due to the sheer size of the dataset. After completing this normalization of the necessary variables, the variable importance became much more balanced with no one variable holding the majority of the decision power.